In this video, I'd like to talk about the concept of factoring quadratics. And you can see I have this example here where this is a quadratic expression. And we know it's a quadratic because the highest power of x is x squared. And essentially in this video, what I want to show you is that you can factor this into a product of two binomials. And remember, a binomial essentially is just two terms. So something like x plus 2 would be a binomial. So when we factor this, we can essentially transform this expression into these two binomials multiplied together. And what I'll show you is that when you do factor this, you get x plus 2 times x plus 1. So this is my claim right now that these two are equivalent to each other. And let me first prove it to you by using the FOIL method to multiply out these two binomials. And the first terms, this x and x, would give us x squared. The outer terms, this x and positive 1, would give us plus 1x. The inner terms, this plus 2 and positive x, would give us plus 2x. And finally, we have the last terms, this plus 2 and this plus 1, which would give us plus 2. And from here, you can essentially just combine it, since plus 1x plus 2x are like terms. So you end up with x squared plus 3x plus 2. And what I want to show you is that going from this quadratic expression to this factored form is essentially using the FOIL method, but in reverse. So let's see if we can notice some patterns here. And essentially what you can see is that the first terms multiplied together in the FOIL method, this x and x here, form the x squared term. So essentially the first ones form the term with x squared, whereas the last ones in this FOIL method, the plus 2 and the plus 1, notice that they multiply together to give us the constant term in our quadratic expression. And furthermore, what you can notice is that the outer and the inner terms added together, the plus 1x plus 2x, ended up being this middle term with x in it. So in summary, the first terms in the FOIL method create the x squared, the last terms create the constant, and the outer and the inner combine to give us the 3x, or in other words, the x term. So let's try and apply this method, but to a different example problem. So in this problem, we have x squared minus 3x minus 10. And we want to see if we can factor this into a product of two binomials. So essentially, we're going to have two terms in each of these. And as we discussed above, we're going to use the FOIL method, but in reverse. So essentially, these first terms, these terms right here, are going to form the x squared term. So in this case, they would have to just be x and x. And we also know that the last terms form this minus 10. So this term here and this term here would have to multiply to give us negative 10. And at this point, we essentially have to look at the different possibilities, because we also know that the outer and the inner terms right here are going to combine to form our minus 3x. But let's first think about which possible numbers can multiply to give us negative 10. So we could have minus 5 times 2 to give us negative 10. We could have negative 2 times 5 to get negative 10. But we could also have 1 and negative 10, or negative 1 and 10. And these are essentially all the different possibilities of pairs of numbers that can multiply to give us negative 10. And so the numbers that are going to go in each of these slots are essentially one of these combinations. And so at this point, you have to ask yourself, which of these combinations here adds up to this middle term here? So which pair of numbers adds up to negative 3? And that would be the minus 5 and positive 2. So if you put in minus 5 and plus 2, then this should be the factored form of these two binomials. But in the beginning, you always want to get in the habit of using FOIL to test, or essentially to test your answer, just to make sure that it's correct. So let's remultiply this out. The first ones give us x squared. The outer ones give us plus 2x. The inner ones give us minus 5x. And the last ones give us minus 5 times positive 2, which would be minus 10. And when we combine these, we get x squared plus 2x minus 5x is minus 3x, and then minus 10. And since this was the original expression that we started with, we can feel very confident that this factoring here into these two binomials is in fact correct. And with that, let's move on to another example problem. So this example is essentially using the area model, that this expression here, this x plus 2 times whatever the width is, which will be another binomial expression, that these two multiply together to give us this quadratic expression here, this x squared minus 4x minus 12. So essentially, we have that the width multiplied by x plus 2 would give us x squared minus 4x minus 12. So essentially, we need to factor this expression, x squared minus 4x minus 12, but they've already given us one of the binomial factors. So we just have to figure out what the other one is. So let's start this by essentially just looking at the FOIL method, but in reverse. So we know we have these two binomials, and we know one of them is x plus 2. And so what we know based off the FOIL method is that the first terms, this one and this one, give us x squared. So that makes this one x, essentially, since x times x is x squared. And we also know that the last terms, essentially this one and this one, multiply to give us negative 12. So in this case, we don't have to go through the guess and check work since we already have one of the numbers. So we essentially just have to ask what number multiplied by positive 2 would give us negative 12. And in this case, it would be minus 6. So at this point, we've found an answer, but we want to check it. So let's re-multiply this out using the FOIL method. So the first ones give us x times x, which is x squared. Then we have x times positive 2, so plus 2x. Minus 6 times x, which is minus 6. And the last terms, minus 6 times positive 2, which is minus 12. And when simplifying these like terms in the middle, you get x squared minus 4x minus 12. And since this expression was the expression that we started with, we can feel very confident that our width is equal to this binomial expression here, x minus 6. And let's move on to one final example, just so that we can feel a little bit better about factoring these basic quadratic expressions. So to factor this expression, let me first start by just rewriting it. So we have x squared minus 10x plus 21, and we're going to set this equal to a product of two binomials. We'll be able to factor it into these two expressions multiplied together. And as above, we will continue using this FOIL method, but essentially in reverse. And so we know that the first terms, this one and this one, multiply to give us x squared. So in this case, they would have to be x and x, since those two multiplied together do give us x squared. And we also know the last terms multiply to positive 21. So this term and this term have to multiply to give us 21. So let's think about the different combinations of numbers that will multiply to give you 21. And we can do 1 and 21, or you can do minus 1 and minus 21, since both of these do multiply to give us 21. You can also do 7 times 3, or minus 7 times minus 3, since in both cases you get positive 21. And once you write down all the different possibilities, now you just have to ask yourself the question, which of these pairs of numbers would add up to give us this middle term here, this minus 10x? Or essentially, we're just looking for the coefficient on x. So which of these pairs would add up to give us minus 10? And in this case, it would be this minus 7 and minus 3. So we can put minus 7 and minus 3 into our binomial expressions. And let's test this by using the FOIL method to multiply it out. So when you do that, you get x squared for these first terms. The outer terms give you minus 3x. The inner terms give you minus 7x. And the last terms, the minus 7 times minus 3, would be a positive 21. And from here, you can combine these two middle terms since they're like terms. And when you do that, you get x squared minus 10x plus 21. And since this was the original expression that we started with, we can feel very confident that this expression here is correct. And in a later video, we're essentially going to talk about how to factor expressions when the coefficient on x squared is not 1. So essentially what happens when you have something like 2x squared plus whatever the lower level terms are. And how can you factor this one?